All right, so we are going to start talking about factoring. This is Unit 9 in Algebra 1. So this is our last unit for the semester. This packet was actually the packet I passed out on the last day we were in school. So if you were there, you might remember I passed out that packet. Feel free to use that as a note or reference sheet. I will be pulling the questions for this video from that packet. If you are absent or maybe you have lost the packet, no worries. I will continue to post note sheets and reference sheets on Google Classroom so you can download or print those out instead. So what exactly is factoring? Well, if we think about just a number, so if we look at 35, if we wanted to find factors of 35, we would want to think about two things that multiply to 35. So we could say that 35 is the same thing as 7 times 5. The same thing applies with polynomials or monomials. So if we wanted to look at something like 2x squared y, there are many different ways we can write this, but if we pull this apart and rewrite it as a product of two things or multiplying two things, they would be called factors. So we could say that two factors of this would be 2x times xy. And like I said, there are many combinations here. I'm just giving you an example of what factors look like. So this whole unit is going to be looking at polynomials and how we can pull them apart into two different things that would multiply to that original expression. These examples can be found on page 2 of the note packet that I passed out the last time we were all in school. This can also be found on the first page of the reference note sheet that I posted on Classroom for this week. So feel free to have both of those ready to go. You can fill in the examples as I do them in the video. So the first type of factoring that we are going to talk about is factoring out a GCF. You should recognize that phrase. A greatest common factor is something that we talked about at the beginning of Unit 8. So feel free to go back to that Unit 8 note packet if you need a refresher. What we're going to do is factor out the GCF of the terms that we see in the polynomial. And what that means is we're going to pretty much do the opposite of the distributive property. So we're taking a simplified polynomial and working backwards. So for example, in number 1, we have 7x squared plus 14x. So the first thing I'm going to do is look for the GCF. 7 and 14 both have a common factor of 7. And they both have a variable of x. One is x squared and the other is x to the first. Anytime we're talking about a GCF, you want to choose the one that has the smaller exponent. So for this first example, our GCF is just 7x. This first step should be somewhat familiar. The next step is where we're going to actually factor that greatest common factor from the original polynomial. So this is always written in front of the parentheses. And then to figure out what's inside the parentheses, we're actually going to divide by the GCF. Remember, this is like the opposite of distributing. So it's the opposite of multiplying. So we're going to divide each one. And remember rules of exponents, when you're dividing, you subtract exponents. So if we divide the first term, 7x squared divided by 7x, we just get x to the first. And then 14x divided by 7x, we get positive 2. And the x's would cancel. So this is actually our answer. And if you notice, it looks a lot like a problem we probably would have done in the last unit, where we had to distribute the 7x. So I just want to state we are doing the opposite. So don't go ahead and multiply, because if you multiplied now, you would just end up back at the original question. Okay, so this is our answer. This is the factored form. All right, so let's try number 2. In this case, we have 3 terms, so we want to look for the GCF in all 3. Start with the numbers. We have 15, negative 30, and 5. They all have a factor of 5. If we look for x, all 3 terms have an x. Pick the one that is a smaller exponent, which would be x to the first. If we look for y, not all 3 terms have a y. So if they don't all have y, we cannot include that in our GCF. All right, so next step, we're going to pull that GCF out of all three terms, meaning we're dividing all three terms by 5x. In the first case, we would end up with 3y, and the x's would cancel. In the middle, we would get negative 6xy. We're just subtracting our exponents for x. And then in the last one, 5x divided by 5x, they do both cancel. 5 divided by 5 is just 1, and the x's would also cancel to 1. Be careful because this is not 0. You can't skip writing this 1 at the end. So it's going to be very important anytime things cancel. When we're dividing, that really means it equals 1, not 0. All right, number 3. It might be tempting to distribute because we're so used to simplifying expressions, but this is actually already in a form where we can factor out a GCF. So if you notice both terms, if we think of the terms being the 5 times x minus 4, and then the second term would be the x times x minus 4. Both of those terms have an x minus 4. So our GCF is going to be that entire expression. So as always, we're going to write the GCF out front and then open up a set of parentheses to include whatever we have left after dividing. Now, if we divide each of these by x minus 4, notice that we can still cancel these out and have something left over. So in the first part, when we cancel out x minus 4, we have a 5 left over. In the second part, if we cancel out the GCF of x minus 4, we still have that x that was out front. So while this case is a little bit different, it can be factored in a similar way, where we're just factoring out the GCF. In example 4, we're going to look for a GCF first. So between 10 and 3, the only common factor they have is 1. And then if you look, the variables are clearly not the same. X is not included in both terms, and neither is y. So meaning this does not have a GCF. So what this means for factoring is that this polynomial would be considered prime. And we would use this answer anytime we're talking about a polynomial that cannot be factored. So this is a prime polynomial. Moving on to number 5, we're going to look for our GCF. Our coefficients are 6 and 12, which both have a factor of 6. If we look, both terms have a. Pick the smaller of the two, so a to the third. And both terms also have b. So we're going to choose b squared. The GCF gets written in front. And then we're opening that set of parentheses for when we divide. So if we're dividing both of these terms by our 6a cubed b squared, we're dividing coefficients and subtracting exponents. So 6 divided by 6 is 1. Our a's would cancel and our b's would cancel, but we still need to include that 1 for the first term. In the second term, we have negative 12 divided by 6, which is negative 2, and then we're subtracting exponents to get a squared, b squared. So this would be our answer for number 5. So go ahead and try the you-try questions on the rest of this page. Check out the next video to see how you did, and let me know if you have any questions.